Today's lesson is expressing probability with numbers. Previously, we talked about how we can express probability with words. We use words like unlikely, probably, maybe to express the chance that some event might happen. But we're going to focus now not so much on descriptive words, but how to express probability using numbers. So we're going to start out with a coin toss. Here I've got a penny, and on the penny there is a heads side and a tails side. And so if we say that we want to flip this coin and we want it to land on tails, we know that there's only one side with tails and there's two possible things that could happen. So what we do to write this out in math, since probability is a long word, and we don't really want to write long words if we don't have to, in math we use the capital P. Capital P means probability, and then in parentheses we write the thing that we're looking for, the thing that we want to happen. So if we want tails to happen when we flip the coin, then we write capital P for probability, tails in parentheses. And the way we read this is the probability of getting tails. I want you to say that now. The probability of getting tails. All right, and then we put an equal sign because we're going to use numbers. So the probability of getting tails when we flip, we said there's only one side that has tails, so one goes on top. And the total things that can happen, what are all the things that can happen? Well, heads and tails, well, heads or tails could happen. So there's two things that could happen, and that goes on the bottom. So the probability of getting tails equals 1 out of 2. Let's try it just to see what happens. I got it. Tails. There it is. All right. Let's move on. We're going to try dice. Well, just one die, actually. When you have two or more of these, they're called dice. But one of them is actually called a die. A die is a six-sided cube with dots representing numbers. Okay, so a die is a six-sided cube with dots representing numbers. Since it has 6 sides and it starts with 1 and goes all the way up to 6, that means we've got 6 numbers. So there's 6 different things that can happen when I roll a die. I roll the die, I could get any one of those numbers, okay? So let's say we want to know what's the probability of rolling greater than 4. So the probability that when I roll a die, I'll get a number greater than 4. Okay, so we have to ask ourselves, if this is the thing that we want, greater than 4, how many of the numbers actually are greater than 4? Well, there's only 2 of them. There's a 5 and there's a 6. So there's 2 things that will satisfy what we're looking for. And then what are the total number of things that could happen when we roll the die? Well, there's 6 of them. So that means the probability of getting a number greater than 4 is 2 out of 6. All right, well, one thing that you're often asked to do in probability is not just write a ratio or a fraction like that, but you're asked to convert the fraction into a decimal or a percent. So let's practice that right now. How do we change 2/6 to a decimal and a percent? You might remember that during the school year we've used what we call a portions web, like this. And so we've practiced this before. We would always put the fraction at the top, and the decimal would go here, and the percent would go over here. So how did we do the portions web? How do we change a fraction to a decimal? Well, you might remember that we divided. So 2 divided by 6. 6 goes into 2? No, it doesn't. So we're going to need to add a decimal and some zeros. 6 doesn't go into 2, but it goes into 20 3 times. 3 times 6 is 18. Take away is 2, bring down the 0. 6 into 20 is 3. That's 18. Take away is 2. It's going to be 0.333 repeating. So we could say this is the same as 0.3 repeating. Or we could just say it's 0.33 and we could stop it right there. And the reason we might want to do that is because if we want to change this to a percent, it's good to have a couple of decimal places. Because when we change to percent, we're going to move the decimal point 1, 2 places to the right, and it becomes 33%, right? So we could call this 33%. So that means that the probability of rolling a die and getting a number greater than 4 is 2 out of 6, which is the same as 0.3 repeating, and that's the same as 33%. So all of those are good answers for this question. Let's roll it and see what happens. See if I can get a number greater than 4. No, I got 4, but that didn't work because I wanted greater than 4. That's all right. Okay, let's move on to some cards now. Okay, here I have some cards, and I've got a king, a 2, a queen, a 9, and a jack. You may not be familiar with the term face card. What kind of card is a face card? A face card is a card that has a face, like a king has a face, the queen has a face, the jack has a face. These are not face cards. There's no face drawing on there. So if I take the cards and I mix them up and I say, what is the probability that you could choose one card and get a face card? So let's see, we're going to write probability of a face card. We want to choose a card that has a face. So I'm just going to pick one at random. I didn't get one. But there were 3 possibilities of getting a face card. So let's write the probability of getting a face card is 3 out of how many total cards were there? 5 cards. So 3 out of 5 was the probability of getting a face card. It doesn't always happen. As you saw, when I chose a card, I got the 9. But at least the chances are pretty good. We could say 3 out of 5 chances. That's a pretty good probability of getting a face card. Let's change that, though, into a decimal. So we want to change 3/5 to a decimal. We'd have to do 3 divided by 5. The number on top goes inside the box when we divide. 5 doesn't go into 3, so we're going to put a decimal and some zeros. 5 goes into 3 0 times. 5 goes into 30 6 times. 6 times 5 is 30. Take away is 0. That's it. We don't need to go any farther when we have a remainder of 0. So 0.6. So this is the same as 0.6. Can we change that to a percent? Let's see, 0.6 changed to a percent. We need to move it, the decimal 1, 2 places to the right, so then we put a 0 in there. 60%. So 60% chance of getting a face card in this situation where the 5 cards are there, 3 of them are face cards. That means you have a 60% chance of choosing a face card. All right, one more. What's the probability out of these 5 cards that I would mix them up and have you choose one and you would choose a red card? What's the probability that you would choose a red card? Well, we got 4 black and 1 red. So it would be 1, the probability of a red card would be 1 out of 5, because there's 1 red card out of 5 total cards. Okay, what's the decimal and the percent there? 1 divided by 5. That goes in there 2 times, 0.2. Yep. So it's the same as 0.2. And then if we want to change that to a percent, what percent is that? 0.2, move it over twice, becomes 20%. So we have a 20% chance, or 1 out of 5 chance, of getting a red card when you've got 1 red card in 5 cards total. All right, I want you to practice this by doing the Google form that I'm putting on Google Classroom. Have a great day.